Today we're going to do an introduction to matrices. What is a matrix? A matrix is a rectangular array of numbers. We use matrices to display data. So in our matrices, we have rows and columns. So this would be row 1, row 2, and row 3. And then columns go this way. So this would be column 1 and column 2. So matrix A, we would call this, is a 3 by 2 matrix because it has 3 rows and 2 columns. These dimensions tell us the size of the matrix. We name matrices using a capital letter. And the dimensions of a matrix are written in order of rows by columns always. So let's talk about the elements of a matrix. Each element or value in a matrix is called an entry. Each entry is written by naming the row and column in which it lies. This is also known as its address or location. So the element B2, 3, and remember, it's always row, column, means we want row 2, column 3. So if we look at row 2, that would be the bottom row down here. Column 3 would be 1, 2, 3, so -1. The next one says the element B1, 4, which is row 1, and then column 4. So row 1 is the top row. Column 4 would be the last in the row, the last number, which is -2. B21 is row 2, column 1. So row 2, column 1 is pi. The entry 5 appears at what location? So the entry 5, notice, is in the top row. So that's row 1 and column 3. So this would be 1, 3, and since this is matrix B, we could write B1, 3. So this again is row 1, row 2, and this is the columns. Columns 1, 2, 3, and 4. What are the dimensions of matrix B? So matrix B, if it has 2 rows and 4 columns, it's a 2 by 4 matrix. Next, let's talk about matrix addition and subtraction. You can add or subtract matrices if they have the same dimensions. Simply add or subtract corresponding entries. So let's look at some examples here. We have matrix A plus matrix B. So let's look at the dimensions of each matrix first. So remember, it's always row by column. So matrix A has 3 rows and 2 columns. Matrix B has 2 rows and 1, 2, 3, 4 columns. So again, you can only add or subtract matrices if they have the same dimension. So a 3 by 2 is not the same as a 2 by 4. So that means that there is no solution. You cannot add because the dimensions are not the same. So not the same dimensions. Looking at the next one, we're doing matrix A and we're adding that to matrix C. So let's look at the dimensions of matrix C. So again, remember, it's always row by column. So the number of rows we have are 1, 2, 3, and the number of columns are 2. So remember, rows go this way, columns go this way. So that means that if we're adding matrix A and matrix C, this can be done because, again, they have the same dimensions. So all we have to do is add or subtract the corresponding entries. So if we look, this first entry which is row 1, column 1, we would just add 7 plus 4.5. The next one, if we go to row 1, column 2, negative 1 plus 9. And then row 2, column 1 is 6 plus 3. Row 2, column 2 would be 0 plus 2.5. And then row 3, column 1, negative 1 plus 2. And 3 plus 1 would be row 3, column 2. And if we add those together, we get 11.5, 8, 9, 2.5, 1, and 4. So that would be our answer matrix. Now we have matrix B minus matrix C. So matrix B is a 2 by 4 and matrix C is a 3 by 2. So we cannot subtract these. So this is no solution. Cannot subtract. Dimensions are not equal. And then looking at the last one, we have matrix D minus matrix B. So we need to figure out the dimensions of matrix D. It has 2 rows by 1, 2, 3, 4 columns. So for this one, if we're subtracting matrix D from B, and yes, order matters, you can subtract them because again, they have the same dimensions. So in this case, again, order does matter. So we want to subtract D from B. So this would be 12 minus 3, 0 minus 9, 1 minus 10, negative 3 minus 5 for the first row. And then the second row would be negative 4 minus negative 8, negative 6 minus 7, 2 minus negative 3, and 9.5 minus 0. So then we end up with our answer matrix. 12 minus 3 is 9, and then negative 9, negative 9, negative 8, 4, negative 13, 5, and 9.5. So that would be our answer matrix. Okay, next part. Multiplying by a scalar. To multiply an entire matrix by a number or a scalar, multiply each entry by the scalar. The result is called the scalar product. So if I want to multiply matrix A by 4, I would again multiply each entry by 4. So 7 times 4 gives us 28. 4 times negative 1 is negative 4. And then row 2, 4 times 6 gives us 24. 4 times 0 is 0. I should have made this a little bigger. 4 times negative 1 is negative 4. And 4 times 3 is 12. Over here, we would do the same thing, multiply 2 times all these numbers in our matrix, and then we would add that to the second matrix. So just by multiplying by 2 for these, we would get 2 times 3, which is 6. 2 times 9 is 18. 2 times 10 gives us 20. This would be 10, negative 16, 14, negative 6, and 0. And we're adding that to the matrix above. So when we add these, then you're adding 6 plus 12. So that gives us 18. 18, because 18 plus 0, 20 plus 1 is 21. 7, 10 minus 3, 6, negative 16, and negative 4 gives us negative 20. 14 minus 6 is 8. Negative 6 plus 2 is negative 4, and 9.5. So that would be our answer matrix. All right. Multiplying matrices. The matrix product is the product of two or more matrices. You can only multiply matrices when the number of columns in the first matrix is equal to the number of rows in the second matrix, and order matters when multiplying matrices. So again, the number of columns in the first matrix is equal to the number of rows in the second matrix, so that's important. So looking here, notice we have matrix A. A is a 3 by 2, so 3 rows, 2 columns, and matrix B is a 2 by 2 matrix. So the product of A, B, it says, is a 3 by 2 matrix. So again, the only reason we can multiply these is because these numbers are the same and the outside numbers are the product. And again, the order in which you multiply does matter, because if we were to do this in reverse, if we did matrix B times matrix A, notice that the inside numbers are not the same. So we cannot multiply. And there would be no answer to that problem. So let's go ahead and you try tell whether each product is defined. If so, state the dimensions. So this one's doing matrix E times F. So this is in order already. So we have to look here and see if these two numbers are the same. So this number and this number are the same, which means that your product is going to be a 4 by 3 answer. So yes, and the matrix is a 4 by 3. Looking at the next one, G times H, it's already in order. So this would be 1 and 2 right here, which is not the same. So no, and it's not defined. So no and not defined. Now this one is a G times F, so this is in order. So we have 1 and 2 right here. So again, this is not the same. So this is not defined. Looking at the next one, we have matrix F times G. So this is not in order. So F is a 2 by 3, and we're multiplying that by G, which is a 3 by 1. Because if you look at it in the order that it's in right now, you might say, no, you can't multiply them. But again, it's F times G, and order matters. So notice the inside numbers here are 3 by 3. So yes, we can multiply those because they're the same. And that's our product answer. So yes. And the answer matrix is a 2 by 1, because you always take those outside numbers for the product. So the next question is, well, how do we actually multiply these? So we're not going to talk about multiplying these by hand, but we definitely can multiply them by hand. It's just we're going to go ahead and use our calculator because it's a lot easier. So go ahead and get out your calculator. And again, I would follow along the steps. So in our calculators, when we have them out, we're going to hit, it says press second, and then the X inverse key, which is right below math. So if we turn it on and hit second, and below math is the inverse key. Notice that the word above there is in blue that says matrix. Anytime you hit the second key and a button, it always does what is in blue on top. So again, that's matrices. And so you'll notice you have these different things. You have the names, the math, and then edit. So we're going to arrow over to edit, and we're going to edit the first one, which is matrix A. And over here we have, you can see a matrix A is a 2 rows by 4 columns. So we need 2 by 4. And we're just going to hit enter to enter these numbers in. So -7, enter, -1, enter, 4, enter, 13, enter. And then we have 0, 5, -6, and -2. So now that we have that, we are going to go ahead and input the dimensions for the next matrix. So to get out of here, you can hit second mode to quit you out, and then we're going to do second matrix, right arrow or left over to edit. And now we're going to do a different matrix. So let's go ahead and do B since this one says B here. And this one is also a 2 by 4 matrix. So 2 enter, 4 enter. And then we're just going to enter the elements for each entry. So 3, -5, 9, 24, and then -9, 1, -16, and -11. Okay. So now that we have our 2 matrix in, I'm going to go to second mode to go back to my home screen. And we're actually going to use these to add the matrices together or multiply them or whatever operation it is that we're doing. So let's say we want to add matrix A and B. So if I want to add matrix A and B, in this case, because if we go up here, if we try to multiply these, we couldn't do it because again, the inside number would be 4 and 2 no matter which way we do it. So we'd have to add these together because they're the same. So we go to second and hit the matrix button. And instead of going to edit, we're just going to hit enter on the name. So we're going to do matrix A plus second matrix and scroll down to B. And that's how we can do the operation. So if we add these matrices together, this would be our solution. And we could do the same thing if we wanted to subtract. So matrix, second matrix button. So A minus matrix B. And if we wanted to multiply, as I said again, we know that we can't multiply these. It'll say an error because those inside numbers aren't the same. So notice it says error dimension mismatch. So we know we can't multiply those, but you can do that operation as well. So those are the steps to doing this. So take a minute to pause the video and do this next example on your own. When you're done, you can unpause to check your work. So in our calculators to do this one, we go to second matrix and I would have to go over to edit. And now I'm doing a 2 by 3 instead of 2 by 4. So 2 enter, 3 enter. And you can clear these out by writing over them. So 4, 7, and 2. And then we have 3, 6, 5. And that's for matrix A. And so then I'm going to hit the second matrix button again and go over to edit. And I'm going to do, instead of E, I'm going to do this in B, and I'm going to write a B here so don't forget that that's in matrix B on my calculator. You could scroll down to E if you want to. It's just, I don't know, I always just do the ones in a row, but it doesn't really matter. So if you wanted to scroll down to matrix E and put it in there so it's the same, that's fine. So we have a 2 by 3, or sorry, 3 by 2, 3 rows and 2 columns. So 3, 4, -1, 0, 6, 2. And so I'm on my home screen. I'm going to do matrix A, so the name of that, times that. And you can put the multiplication symbol if you want, but you don't have to. And matrix E for me is in matrix B. And so when we multiply that, the answer matrix is 17, 20, 33, 22. So again, this was a 2 by 3, and this is a 3 by, 2 by 3, and this is a 3 rows by 2 columns. So that's why we can multiply it, and then our product matrix is a 2 by 2. So notice this is 2 by 2. All right. So here we have some practice problems. And again, when you're using your calculator, if you want to scroll all the way to letters, you can go all the way down, but it doesn't have, if you notice, like W, X, Y, and Z. So what I would do is whatever letter you put them in on your calculator, I would just write them out. So like if you do this as A, B, C, and D, so you don't get confused. And actually, I think the ones that are just adding and subtracting are a lot easier just to do by hand than having to type them in, but you can type them in as well. So go ahead and practice these on your own and pause the video. And when you're done, on pause. So after practicing these, I'm just going to write the answers here so that you can see them. All right, so make sure to, again, check your work here and notice that 3 and 5 don't have any solutions because for 3, you can only add or subtract when you have the same dimensions, and these are not the same dimensions, so it's not possible. And for number 5, x times w, notice the inside numbers 3 and 2 are not the same, so you cannot multiply these if no solution or not possible. So let's go ahead and take a look at an application problem. It says that Double Batch Cookie Company currently sells 2 types of cookies, their signature chocolate chip and newly created cinnamon pumpkin cookies. The table on the left shows the number of batches of cookies sold in the months of October and November for each type of cookie. The table on the right shows the revenue, cost, and profit for each batch of each cookie. By creating a matrix for each table and then using the matrix multiplication, we can determine the total cost, revenue, and profit for both types of cookies for the months of October and November. So here the matrix would be 2 by 2. So we have 15, 24, 11, and 16. And over here we have 25, 15, 26, and 14. So again, this is a 2 by 2 matrix, and this is a 2 by 3. So we know we can multiply these, and the product matrix is going to be a 2 by 3. So we're going to go ahead and put this into our calculator. So in my calculator, I'm going to go over to edit. We have a 2 by 2 matrix, 15, 24, 11, and 16. And second matrix, we're going to now do matrix B as a 2 by 3, 25, 15, 26, and 14. And now we are multiplying that first matrix A, because we put this one in as matrix A, and I put this one in as matrix B. So a lot of times it's helpful to write that down so you don't forget. So now we are naming the matrix. C is not in there. All right, so we're doing matrix A times matrix B. So then our answer matrix, we have 750 19, 561, 540, 151, and 389. And so that just tells us for that specific month, we can figure out the revenue, cost, and profit for each batch of cookie that we had with this matrix right here. So in October, the revenue was $750. The cost was $219. So the profit was $561, etc. Looking at example number 2, the first table shows the number of reams of paper, packs of dry erase markers, and boxes of staples requested by 2 teachers. The cost per item is given in the second table. Use matrix multiplication to show the total cost of supplies for each teacher. So for this one, we would have our matrix would be a 2 rows by 3 columns. So 6, 4, 5, 8, 2, 3. So this is Miss Smith and Miss Willis. This is paper, markers, and staples. And we are multiplying that. So this is, I'm going to put this as A. This is again, 2 rows by 3 columns. We're multiplying this, and I'm going to call this one matrix B. So we have paper, markers, and staples. So this is going to be 3 rows by 1 column. So $15, $4, and $2.50. Because in order to find the total cost, you're multiplying the amount by what it costs for paper, markers, and staples. So in your calculator, we're going to have to enter these in. So second matrix, I'm going to enter that first one into matrix A. Let's get to edit. And that's a 2 by 3. So 6, 4, 5, 8, 2, and 3. And second matrix, now we're going to edit matrix B. And this is a 3 by 1 matrix. So 15, 4, and 2.5. And so for this, if we go out of here and do matrix A times matrix B, that gives us our product, which we know we can multiply these, and the product is a 2 by 1 matrix. So 118.5 and 135.5. So that means that Mr. Smith total cost of the supplies was $118.50, and Miss looks like Miss Wills total cost of supplies would be $135.50. And again, there is a way that you can multiply matrices by hand. So if you want to look that up on your own, you can. It's always you multiply rows by columns. But again, I'm not going to make us do it by hand, so you can just use your calculator.